Okay, we have a velocity time graph here, and I just wanted to go over one more time what all that means. First of all, you always have to look at your y-axis and be sure you know what kind of graph you have, because if it's a position time graph, that's going to be a lot different from a velocity time graph. So we have a velocity time graph here, meaning that we have, it's in meters per second, and hold on, let me get my pen to work here, maybe. And so it starts out right, whoops. All right, come on, pen. There it is. It starts out right here. And let's just say that, let's see what we have here. 1, 2, 3, 4. Let's say this is -4. All right? So that's going to be -4 meters per second. Well, this is a positive slope. And remember, slope equals acceleration or velocity time graph, all right? And so if this is a positive slope, that means this has a positive acceleration. And let's just call these numbers down here 0, 1, 2, 3, 4, and you get the idea. 5, 6, 7, 8, 9, 10, 11 seconds. So if I go from -4 to 0, right, this is the x-axis, so that's 0 meters per second, then I can find the slope of this line, which would be final minus initial, so it would be 0 minus a -4. So 4 will be the change in y, +4. My change in x would be 3. So the slope would be 4/3, which would be about 1.33. So the acceleration for the first part is positive 1.33 meters per second squared. All right, that's for the first part. Now, that's a positive acceleration, but notice this is going from -4 to -3, all the way up to 0. So it's slowing down with a positive acceleration. And that's because this is a negative velocity. So negative velocities are all down here below the x-axis. Positive velocities are all up here above the x-axis. And anytime your acceleration and velocity signs are opposite, you're slowing down. All right, well, what does it mean when it hits this line? Well, this line is 0, so from 3 seconds to 5 seconds, it's not moving. Velocity equals 0. It's not moving there. All right. Now, what happens here starting at 5 seconds? Well, from 5 seconds to 6, 7, 5 to 7 seconds, it has a positive slope, another positive acceleration. So if this is 1, 2, 3, 4, 5, so it goes up to 5 meters per second, +5. Then I'm going to have a change in y of 5 and a change in x of 1, 2 seconds, right? So it's going to be 5 divided by 2 for my slope. So for this part, I have a positive acceleration. That positive acceleration equals 2.5 meters per second squared. And I also have a positive velocity. So that means I'm speeding up. So from here to here, and let's do this. Let's call this section A, so I can always refer back to it. This is section B, this is section C, and this is section D. So here's the question. As I move from time t equals 5 to time t equals 7 seconds, what happens? Well, I accelerate at 2.5 meters per second squared. My velocity is positive, so I speed up. I speed up from 0 meters per second to +5 meters per second. Here, it's a positive acceleration, but I slow down from negative. Now remember, negative, all negative means, it means I'm going this direction to the left. That's negative. I'm sorry. Let me erase that. Okay. That's negative. And if I move this direction, that's positive velocity, right? And so I'm moving to the left here, and I'm slowing down from -4 to 0. And then for a couple of seconds, I stop because I'm on the 0 line. That's 0 meters per second. Then I go from 0 meters per second to 5 meters per second in 2 seconds, and that's a slope of 2.5. So I'm speeding up 2.5 meters per second squared. That means every second I speed up another 2.5 meters per second. All right, what does this mean right here? A lot of people want to say stop, but it is not. It's not stop. This is constant. The only place to stop is if you're on the 0 line. So from 7 seconds to 8, 9 seconds, I am going at constant velocity of 5 meters per second. So here's what we can do. Maybe this will make sense. A is slowing down. Section B is speeding up. And both of these have a positive acceleration, but one, section A, has a negative velocity, and the other, section B, has a positive velocity. So you can have the same type of acceleration, positive, because it's a positive slope, but still be either slowing down or speeding up depending on your direction you're moving, all right? Section C is constant speed, constant velocity, because it does have a direction. What is that direction? Well, I'm above the 0, so it's positive, and that's going to be positive 5. So what's happening in section D? All right, well, in section D, I have a negative acceleration, and I'm slowing down. Slowing down. And this is a negative acceleration. All right, but it's a positive velocity. All right, so I'm slowing down. So in 2 seconds, I go from 5 meters per second to 0. Now, let me change something here. Let's take another line and let's just move down here a little bit. And, oops, we didn't do that. I didn't even make that line. Let's see if I can move that over just a bit. Anyway, I want it to meet up with that line. I want it to be the same line. So we'll pretend that's the same line. All right. So I have a negative acceleration here and a positive velocity. So what happens when I cross this x-axis? If I cross this x-axis, what that means is I turn around, because right here, for a very brief moment, right there, I stop. And I turn around and I go from moving forward to moving backwards. And you got to be careful of the word backwards, but I'm moving in the negative direction. I'm moving to the left. Here I'm moving to the right. So if we call right forward, then left would be backwards. But here I'm moving to the right, as defined by the normal Cartesian coordinate system. And here I'm moving to the left because it's negative velocity. Why is it negative velocity? Because I'm below this x-axis. This is still negative acceleration, but I'm speeding up. Starting right here, I speed up in the negative direction because I have negative velocity. Up here I have negative velocity, but I'm slowing down because I have positive velocity. So that's just a little review on velocity time graphs. All right, that's just a little review on velocity time graphs. And so kind of soak that in and rewind it and look at it again if you want. I'm going to real quick clear the ink from the page, and I'm going to real quick show you area under the curve. Now, again, if this is -4 and this is +5 and this is 0 to 11 seconds, then we can also find an area under the curve, which is all this area in here, right? So this area right here would be a negative area, and we would find that area by saying it's a triangle, so it'd be 1/2 base times height, and that would be 1/2 times, let's see, that'd be 0, 1, 2, 3 times 3 seconds times height, which is -4 meters per second. I apologize, I didn't put my labels here. Velocity in meters per second and time in seconds. So when I multiply those together, I get meters. And so if I do that, I get 0.5 times 3 times -4, and that gives me -6. So area 1 is -6 meters. Okay, then I have this area up here. And I can, that's a terrible straight line, but I could divide, basically, I can divide this into 2 right triangles and a rectangle. And so, and there's an equation for a trapezoid, but this is real quick if you can't remember that. 1/2 base times height for this one, so that'd be base is 2. So this right here is going to be an area of +5 because 1/2 of 2 is 1. 1 times 5 is 5. Same for this. So I'm going to have 5 here. I'm going to have 5 here. And the units on these are going to be meters, just like the green, negative green area here. And then this one's going to be 2 times 5. So this is going to be 10 meters. And so the total red area, we'll call that area 2, is +10 meters. So let's just stop there and let's find the result of those two. Let's not worry about this one because it's kind of off the scale and I added it. Let's just worry about this green and this red area. And I just sum those up. What does that mean? That means I say 10 plus a -6, which is going to be +4 meters. So my total displacement for this whole thing is delta x, that's displacement, is +4. So that is my total displacement, assuming, now this assumes, all right, that's my total displacement, but assuming that I started at, in other words, sorry, hold on. Assuming that my initial x was 0, like I started out at 0, then I would end up at a +4 away from 0. If I didn't know my initial, then the delta x is still +4. You just wouldn't know exactly what position you were at. You just know your overall displacement was +4. So I hope that helps. Watch that again, and that should help you on velocity time graphs. Thanks.